applications using trigonometric functions. Solving problems using trigonometric functions. Trigonometric functions are used to solve problems that have a periodic behavior. Problems that involve circular movement, perhaps, on a repetitive nature, a Ferris wheel, a bicycle wheel. Or problems involving repetitive motion, such as a spring, which is constantly up and down, left or right. Oscillating waves that you might see in electronics, and tides that come in and out at the Bay of Fundy, for example, if you've been there. Here is a sample problem that we're going to analyze. The water depth in a harbor is 8 meters at low tide and 20 meters at high tide. One cycle is completed approximately every 24 hours. Find an equation for the water depth, d at t meters, as a function of the time, t hours, after high tide, which occurred at 0300 hours. Draw a graph of the function for 24 hours starting at average sea level. Verify your answer using technology. The first thing that you want to do is to read the question carefully, highlighting the clues that are provided in the question. The water depth in a harbor is 8 meters at low tide. Ah, a clue, 8 meters at low tide. And 20 meters at high tide. Ah, another clue. One cycle is completed every 12 hours. One more clue. One cycle, 12 hours. If the water is at average sea level at midnight and the tide is coming in, which means the water is going to rise, find an equation for the water depth, we'll call it d at t meters, as a function of time, which is t hours. One more clue here. High tide occurred at 0300 hours, 3 o'clock a.m. Now, here's the key pieces of information that we've gleaned from the question. High tide is 20 meters. Low tide is 8 meters. The cycle length is 12 hours. High tide occurs at 3 hours and the seabed would be at y equal to 0. Now from there, determine the key values that can be used to draw a sketch of what this function would look like. Clues on the right. Amplitude. High tide minus low tide divided by 2. 20 minus 8 divided by 2 is 12 divided by 2, which is 6. So the amplitude is 6. The axis of curve would be the distance from the seabed to the low tide plus the amplitude. So low tide is at 8 meters, the amplitude is 6, so the axis of curve will be at 14. Determine the key values that can be used to draw a sketch of what this function would look like. Clues. K value is 2 pi divided by the period, which would be pi over 6, or if we're working in degrees, 360 degrees divided by 12, which is 30 degrees divided by 12. D value, if you divide 12 hours by 4 hours, there's a quarter in every major time period, you would get 3 hours. So if you start at midnight, high tide would occur at 3 hours. There is no phase shift. Now, use these values. A is equal to 6, C is equal to 14, K is equal to pi over 6 or 30 degrees, D is equal to 0. The equation, depending on which way you go, 6 sine x pi over 6x plus 14, or y equals 6 sine 30x plus 14. Now, let's sketch the graph. Y equals 6 sine pi over 6x plus 14, or y equals 6 sine 30x plus 14, whether your degrees are radians. Here's the sketch you've made. Draw the axis of curve. C is equal to 14 to confirm. The amplitude is 6. Perfect. Calculate K, either pi over 6 or 30 degrees, depending on what you're working on. And our period is 12 hours. Okay. Sample problem number 2. A carnival Ferris wheel with a radius of 9.5 meters rotates once every 10 seconds. The bottom of the wheel is 1.2 meters above the ground. Find the equation of the sine function that gives the rider's height above the ground in meters as a function of the time in seconds, with the rider starting at the bottom of the wheel. Rewrite the equation using a cos function. Sketch the graph showing 2 complete cycles. Step number 1. Read the question carefully, highlighting the clues provided in the question. A carnival Ferris wheel with a radius of 9.5 meters. Clue number 1. The radius is 9.5 meters. It rotates once every 10 seconds. Clue number 2. 10 seconds. The bottom of the wheel is 1.2 meters above the ground. Clue number 3. 1.2 meters above the ground. We then continue with the question. Now, determine the key values that can be used to draw a sketch of what this function would look like. The radius is 9.5 meters. The cycle is 10 seconds. The bottom of the Ferris wheel is 1.2 meters above the ground. The rider starts at the bottom of the Ferris wheel. Step number 2. Determine the key values that can be used to draw a sketch of what this function would look like. The amplitude. The radius is the distance from the center point of the wheel to a point on the curve. This distance represents the amplitude. In this example, the amplitude, we were told, radius is 9.5, so the amplitude is 9.5. The axis of curve is the distance from the ground plus the amplitude. The distance of the ground, we were told, is 1.2. The amplitude, we were told, is 9.5, so the axis of curve would be 10.7. Now, your solution, step 3, use the values you have determined from step 2 and write the equation. A is 9.5, C is 10.7, K can either be pi over 5 or 36 degrees, D is to the right, 2.5, so our first equation, 9.5 sine pi over 5, x minus 2.5 plus 10.7, or 9.5 sine 36 degree, x minus 5 plus 10.7. Now, step 3, use the values you have determined from step 2 and write the equation as a cos function. Since we start at the bottom, it's going to be a reflection, so we're going to use negative 9.5. It's a cos function. Now, we don't need a shift, so it would be pi over 5x plus 10.5, or negative 9.5 cos 30x plus 10.5. Okay, now we want to sketch your graph, the equation, negative 9.5 cos pi over 5x plus 10.5, or negative 9.5 cos 36x plus 10.5. The graph, the axis of curve, the amplitude, perfect, and the K value, 2 pi over 10 divided by pi over 5, or 36, which we then use in the formula to find our values. Note, in these two examples, we use time as the units of measure. You could also use the radian measure or degree measure as the units of measure. How would you do this, you ask? We know the answer. The maximum point is the distance from the origin to the maximum point, and it is 1/4 of the period length. The midpoint is the distance from the origin to the midpoint, which is 1/2 of the period length. The minimum point is the distance from the origin to the minimum point. You got it, 3/4 time the period length. And of course, the end point is just the period length. Now, if we applied this to this situation, for the Tidal question, 1/4 of pi over 6 is pi over 24. That would be the point for x. The midpoint, 1/2 times pi over 6, which is pi over 12. The minimum point, 3/4 times pi over 6 is pi over 8, and the end point, pi over 6. Wow, we're done. Now it's your turn to put this information in